All right, this is the Gucci Gang 6-1 review for all the cool kids. Okay, so monomial degrees can be a little weird, but yeah, we got some pre-calc all-stars in here that are trying to, so never mind them. So number 1A, this is third degree, right? So that has a special name, doesn't it, Bully? Cubic. Good. All right. This first one has x to the 0 degree, so that is constant. There is no x there. C has, now this is where it gets tricky. We have multiple variables, so we have to add up our exponents. And so this is actually fifth degree, which also has another fancy word, quintic. And letter D has 3 variables, so that one's going to be ninth degree. All right, so watch out for those goofy monomials and their multiple variables. Down here, these should hopefully be the easy questions. Put in standard form, identify leading coefficient degree, number of terms, name it. So standard has the highest degree terms first, so this would be negative 5x squared plus 4x plus 3. That is leading coefficient, negative 5. Degree is quadratic. And that would be a quadratic trinomial. Alright, this next one's kind of a dumb one. Multiple variables, so we have to be careful. Term, 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 term. So how many terms are there? 4 terms. One with the highest degree is the 2x cubed y squared term. 8x squared y minus xy minus 5. Okay. Leading coefficient is 2. Degree, and the name would be a fifth degree or quintic. Fifth degree or quintic polynomial, 4 terms. So anything higher than 3 terms, we don't have a special name for it, like trinomial or so. Polynomial, 4 terms. Okay, there's page 1. There we taped Chloe's animal cracker bag closed, so now it's not so loud in here. That's where all the noise was coming from, all the animals in there. Yeah. Okay, so we're adding polynomials. This is just adding like terms. So you just combine like terms. You take, oh, there's my colors. Good. Quadratic terms together. Add those. I'm just adding them, so I don't have to worry about distributing a negative. So we got negative 30x squared. Take my x terms. Oh, I got a cubic term. Whoa, didn't see that one there. Almost tricked me on that one, Bully. We got to put that one first. 16x cubed out in front here minus 30x squared plus 6x plus, let's see, it's not going to be a plus, it'll be a minus. How about minus 16? Ka-chow? You guys agree with that? Good. All right, next one. This is where you got to be a little more careful when you're subtracting polynomials. Don't forget to distribute this negativo here. So really it's a minus 4x to the 5th plus an 8x minus a 2. All right, put it in standard form. Negative 4x to the 5th. Crime in Italy. Negative 4x to the 5th. Plus 3x to the 4th. Let's see here. Plus 18x. And then minus 11, I think. Minus 11. I'm sure if any of these are wrong, you guys will let me know about it. They always love to do that. Oh, you were wrong in this one. So, yep, I do make mistakes. Lots of them. All right, next page. Oh, products. Hey, now we're multiplying these things together. This is going to take forever. Okay, this is just basically distributive property. All right, so we're just going to multiply x squared y times every term in there. So I have, there's nothing to combine inside of there, so that's simplified. So this is going to be 6 y to the 4th x squared plus y to the 3rd x squared minus 28 y squared x squared plus 30 yx squared. I just put all the y's first because they had a higher power. Okay. Number 6, we have a binomial times a trinomial, so I'm going to have kind of a, I'm going to think of this as like a double distribute. So I distribute the a, and then I distribute the -3 to everything. So I'm going to have 1, 2, 3, 4, 5, 6 different things here. Multiply the a, I'm going to get a cubed minus 5a squared plus 2a. Distribute the -3, I get -3a squared plus 15a minus 6. Alright, clean that all up in the end. You get a cubed minus 8a squared plus 17a minus 6. Lightning McQueen would say, ka-chow! Okay. The last one. Some in the book they use Pascal's triangle. We're not using that this year. No Pascal's triangle this year. So we're just skipping that. So we're just going to do this. Yep, they did not like that. Some pre-calc students did not like that from last year. So we're just doing this longhand. Takes about the same time, really. So k squared minus 6k plus 9 times another k minus 3. All right, now we just got to do the same problem that we did before. So I'm going to pause it and come up with an answer. Whoa, look at me magically did all that work there in like no time at all. Crazy. So I set this one up a little bit, did a 3x2, so I like triple distributed. And hopefully I'm doing this right. So what I got here was k cubed minus 9k squared plus 27k minus 27. And I think that actually would factor by grouping if you, no, maybe not. Anywho, there we go. So that's multiplying. All right, that brings us probably to dividing, everyone's favorite long division. So here we go on the long division. All right. Divide by 2x minus 5. And I do have to fill a 0 on this one. Minus 9x squared plus 0x plus 15. So watch out on filling a 0. Okay, what times 2x gives me 2x cubed? That's going to be x squared. Multiply that by the binomial, subtract it out. I get 2x cubed minus 5x squared. Change both the signs by distributing the negative, so that's going to be a negative, that's going to be a positive. And so what I end up here with is negative 4x. I made that a cubed, that should be a squared. 4x squared plus 0x. Bring down the next thing. Do that again, subtract it. So now what times, see here, what 2x times what is 2x cubed? You do that again with 2x times what is negative 4x. So that's going to be a negative 2. So that's going to be a negative 2, sorry, negative 2x. So negative 2x times that's going to be negative 4x squared. Those should always be the same, and that'll be a plus 10x here. Distribute the signs through, so we go plus, plus, minus. So now down here, this is going to be a negative 10x. Bring down the next term, which is a 15. Do that one more time. Okay, so now we have a my yellow. What times 2x is negative 10x? That's right, negative 5. Minus 5 gives me a negative 10x there, and a plus 25 there. Distribute the signs, that's going to be a minus, that's going to be a plus. So my remainder here is going to be negative 10 over 2x minus 5. So minus 10 over 2x minus 5. Oh boy, there it is, long division. Okie doke, I'm not sure we left off here. Maybe left off, yeah. Long division. So here's a long division question. You had a question on that, Durs, and I just recorded this one here. So if you want to go back and look at that, you can. Synthetic division is next. So synthetic division is a little bit better, kind of shorter, easier, kind of a shortcut method. Works for when you're dividing by a linear term like that. So now I put whatever makes that 0 in the box, 3, and then I record my coefficients of the polynomial. And if I'm missing any terms, so if I'm missing like a quadratic or any degree term, I have to add 0. But in this case, I don't think I'm missing any terms. So I just go through, do my synthetic division, bring the first one straight down, multiply 3 times 3 is 9, that number goes there, and then I add those two. Okay, negative 2 plus 9 is 7, 3 times 7 is 21, add them, 63, and so 59 is my remainder, it looks like. So when I divide that by that, cubic divided by a linear, I'm left with a quadratic, 3x squared plus 7x plus 21, remainder 59x over x minus 3. Okay. You can also, for this synthetic division, you can also do synthetic substitution. This is kind of cheesy, but another use. So if I put 3 in the box there and I have 2, negative 1, I'm missing quadratics, I go 0, 5, and 3. Whatever my remainder is just like evaluating that function if it was a function for f of 3. Okay, so pull the 2 down, do synthetic substitution is what this is called. 15, 45, 50, 153. In case I made any mistakes, don't know, look it over again. So it looks like when you put a 3 in that, I guess you call it this polynomial here, put a 3 in there, you're going to get 153 as your value. Okay. All right. Then we get into some of the factoring. So this first one, factoring, it has 4 terms. It's a cubic. So I'm going to look to see if this one groups. It might not. I don't know. So let's factor out an x squared there. I'm left with x plus 3. Factor out a negative 9 over here, and I'm left with x plus 3. So I know it factors by grouping because these two binomials are common. So now I can factor each one of those out, right? So I get undistributed, I pull those out. I'm left with x plus 3 times x squared minus 9, which can be one step further because x squared minus 9 is a difference of 2 squares. So the fully factored form would be like this. And you could even condense that a little bit, and you could write it, some people are probably wondering, could I write it like this? X plus 3 squared times x minus 3, and you certainly can write it like that. So that's probably the cleanest way to write it. By the way, if you guys have any questions, jump in on this, or go ahead and, yeah. Yeah. Yep. Angelo Perez, you can go to the bathroom. Yep. Next one, number 12, always factor out a common term. So here I'm going to factor out a 8, I believe. Factor an 8 out, and I'm left with an 8p cubed minus q cubed. And that is the difference of cubes. This was Cole's question earlier. So difference of cubes, we have a formula, an identity for that. So that one would follow a minus b times a squared minus ab plus b squared. Actually, it's a plus there. That identity, I'll have that for you on a test. Yep. So now your a in this case is 2p and your b is q. So this is going to be 8 times 2p minus q. And then the other part will be 2p squared, which is 4p squared, minus 2pq, plus, sorry, it's plus there, and then plus q squared. Where did I get the 2p q? There is no 2. This part? The first part? Where did I get that? It's that. And this part right here is that. And I just happened to factor out a common factor 8, so the 8 was just factored out. That has nothing to do with the difference of cubes. So you said what? 8 is what? What was your question? So the A is not, the A is 2p and the B is q, right? So, you know, when you're looking at this, you go, okay, everywhere you see an A, you put in the cube root of that cube, which is 2p, and everywhere you put a B in, you put a cube root of q cubed, which is q. Okay, that brings us down to this number 13 here, and it looks like we can factor out an x and a 5, or negative 5, so let's take a negative 5x out. Should always take a negative. If it's a leading negative coefficient, factor it out. So now we have left is x cubed minus 6x squared minus x, and then plus 6. Okay, I think that actually probably factors by grouping again. So let's group that stuff and that stuff, and we should get x squared negative 1 x minus 6. It groups. We had a negative 5x out there in front, so that's still out there. Keep that negative 5x out there. We factored out an x minus 6, and what was left was x squared minus 1. And that's a happy little math book problem, because now that is the difference of squares. That's nice that that happens. What was that? X squared minus, what the heck just happened there? Yeah, so this is the difference of squares. So this is x plus 1, x minus 1, this is x minus 6, and there was a negative 5x out there. So now that's fully factored form right there. Okay, so just using all the factoring techniques we've learned. Now we're going to do identifying all the roots. So same thing, we use factoring to find these roots, and we also can use synthetic division and rational root theorem. So number 14, this one might unfoil. In fact, it does. If you look at it, it's a higher degree and unfoils. So this would be x squared and x squared, two factors of 18 that add up to 11, negative 11, or minus 9 minus 2. Okay, if x squared minus 9 is a root, then what is going to make that 0? Plus or minus 3. Okay, and if x squared minus 2 is a factor, then what makes that 0 is going to be plus or minus the square root of 2. So the four answers here are 3, negative 3, square root 2, or negative square root 2. All right, number 15 looks like it doesn't factor, and it doesn't factor by grouping, and it's a cubic, so I'm going to have to do the rational root theorem on this one. So let's talk about all the possible rational roots plus or minus p over q. Factors of p. P is your constant term, so it's factors of your constant term, which would be 1, 2, 4, or 8. Q is your leading coefficient, which are factors of plus or minus 1. Okay, so now all the possible rational roots are plus or minus 1, 2, 4, or 8 over 1, which over 1 doesn't really mean anything. So my final list would just be 1, 2, 4, or 8, and that's plus or minus all those. That's 8 values to check using synthetic division. So I really don't want to check all 8 values, so I can use a graphing calculator or a hint or something that sometimes I'll just give you a hint. Hey, are you guys serious about preparing at all for this? Doesn't appear like that to me. All right, so we graphed this and we found that we have possible roots more than likely at 4, -1, and -2. So then I just take those values and I put those in synthetic division. So I guess I'll start with maybe 4. I don't know why. You can start with any one. Doesn't really matter. So I just picked 4. You go 1, -1, -10, -8. Pull the first one down. 4, 3, 12, 2, 8, 0. All right, this will just get me down to a quadratic anyway, so this isn't that big of a deal. Now I'm going to have x squared plus 3x plus 2 as my leftover stuff. So really I'm starting to factor this. I factored x minus 4. I have left x squared plus 3x plus 2, but that also factors into x plus 1, x plus 2. And so there it is right there, and you'll see that's what matched the graph. The roots, if you go back and look at the graph for those. So now identifying all the roots, we've identified all these to be 4, -1, -2. Okay, and they're all verified algebraically using synthetic division. Working backwards, the next one, you'd write a polynomial given the roots. So if -2 is a root, then x plus 2 is a factor. If -1/3 is a root, then x plus 1/3 is a factor. A better way to maybe do that's not the simplest, but would be 3x plus 1, right? And then if 4 is a root, then x minus 4 is a factor, okay? So there would be the simplest polynomial function. If you're asked to multiply it out in standard form, then you have to multiply all that stuff out, FOIL it out. It's kind of a pain, but I'm going to leave it like that. Okay, that brings us to some graphing to wrap it all up. Remember, if the leading coefficient is positive or negative, that tells you what the far right end behavior as x approaches infinity does. So if it goes up, that means the leading coefficient is positive, right? LC positive. If the far right goes down, that means LC, the leading coefficient, is negative. So in this case, the far right of the graph is going up, so the leading coefficient is positive. The other end behavior is going in opposite directions, so that means the degree is odd, just like a cubic graph. Okay, in this case, the far right's going down, so the leading coefficient is negative. The other side's doing the same, so the degree is odd. Sorry, thank you, even. Even. And there will be some questions just like that on the test, probably one. And then there will be one like this as well that says sketch a graph given some roots and know what the multiplicities mean. If they're even multiplicity or odd, whether it bounces back or passes through. So don't forget, if x is a factor, then 0 is a root. -3 is going to be a root, and +1 is going to be a root. So at -3 we have one, at 0 we have one, and at +1 we have one. Okay. If I multiplied this all out, the first term would be x to the 4th, blah, 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 blah. Okay, so that means the leading coefficient is going to be positive, and the degree is even, so that both end behaviors are going to go like that. And the multiplicity is even on -3, so this one it's going to bounce back. All the other ones it passes through. So at -3, it bounces back. So when I sketch this, I'm going to come down from the top, bounce back at -3, and then I'm going to pass through there, and I'm going to pass through there. Looks something like that. Just a sketch, so I don't know if the maximums, the little maximums in between are not accurate. Okay. Same thing over here. -2x means that 0 is a root. X plus 2 squared means that -2 is a root. X minus 3 is 3 is a root. Okay, it's going to bounce a couple times here. It's going to bounce at -2 because the multiplicity is even. And it's going to also bounce back at 3 because the multiplicity is even as well. The leading coefficient in this one would be -2x to the 5th, blah, blah, blah. So that means that my end behavior is going to go down on the far right, and since it's odd, the other side's going to go up. So I'll just put my roots down here. I got 0, -2, and 3. Okay, so now the right side goes down, the left side goes up, and it bounces a couple times. Let's see if I can do this without screwing up. So -2 is going to come down from the top, bounce back. It's going to come back up, go through at 0, going to come back up to this one. I think it's going to bounce again, right? There we go. All right, so that's where we ended. 26 minutes of pure joy. And there's an assignment, which is the other review sheet. Many of you are working on that now. I'll post an answer key to that. So hopefully all of these materials that I've made and all of your effort and concentration will lead to great success.